is complement number z. Find the 3 cube roots of z, giving your answer in the form x plus iy with x and y. Right, so it's already been written in polar form for me. So z is 2 cos of 3 pi by 4. So I have to work in radians on this question now because that's how they've given me the angle. Alright, so this one here then, the mod is 2, isn't it? And the arg is 3 pi by 4. But when I want to find the cube roots and things, I'm going to have to go round more than one cycle. So every time I do a cycle, I'm adding on 2 pi. So I need to rewrite this as 2 cos of 3 pi by 4 plus 2n pi plus I sine of 3 pi by 4 plus 2n pi. Okay, so z to the 1/3 will be 2 to the power of 1/3 cos of 3 pi by 4 plus 2n pi plus I sine of 3 pi by 4 plus 2n pi to the power of 1/3. So by De Morves, what's inside here, that third can come down, so I multiply this by a third. So it's a little bit messy at the moment, so I'll put all the top line over 4, so it'll be 3 pi plus 8n pi, and then when I multiply by a third, I'll go 4 3 to 12 on the bottom, plus I sine, that's going to be the same, 3 pi plus 8n pi over 12. So put an n Newton naught in, I get 2 to the 1/3, n is naught, that's going to just cos of 3 pi over 12 plus I sine of 3 pi over 12. Put n equal to 1 in, I got 2 to the 1/3, cos of, put 1 in there, that's 8, that's 11 pi over 12 plus I sine of 11 pi over 12, and put an n equal to 2n, I got 2 to the 1/3 cos of, right, 2 8s is 16 and 3 is 19, so that's 19 pi over 12 plus I sine of 19 pi over 12. Right, I need to work these out to 3 decimal places. So I'm in radians here, so I need to make sure the calculator's in radian mode, so I'll put that into radian mode. Okay, so this one here is going to be 2 to the 1/3, that's the cube root of 2, so cube root of 2 times the cos of 3 pi over 12. That's 0.891, and then the imaginary part sine, same thing, just change the cos to a sine. And that's also 0.891i. Second, I need to change the angle to 11 pi. And cos. So the 3 decimal places, that's minus 1.217. And then do the sine. Plus 0.326i, and change the angle to 19 pi over 12. The sine is there, so that's what that is. So that's the imaginary part, minus 1.217i. Cos that's 0.326. So there's the 3 cube roots, 1, 2, 3. So part A. So part B, find the smallest positive integer n for which z to the n, right, so z to the n is going to be 2 to the n cos of 3 pi by 4 plus I sine of 3 pi by 4 power of n. By the more, let's bring that n down. That's 2 to the n cos of 3 pi n over 4 plus I sine, sine of 3 pi n over 4. I just want it to be real, okay? So if it's real, then the imaginary part must go to 0. So if it's real, then I want the sine of 3 pi n over 4 to equal 0. So if you think of the sine graph is 0, it's at 0, at pi, 2 pi, 3 pi, okay, 4 pi, so every integer of pi. So if I put n equal to 1 in here, I got 3/4 of pi, no good. Put 2 in, I got 3 pi by 2, so that's no good. 3 in, 9 pi by 4, put 4 in, I get 3 pi, and that puts it there. So if n equals 4, then I've got the sine of 3 pi, which is 0, and then I get the real term when n is 4. Therefore, real when n equals 4. I don't want to know what the term is. I mean, the term then, obviously I'd be putting 4 in here, and 2 to the 4 times that. And then if imaginary, I want the real term to be 0, so I want the cos of 3 pi n over 4 to equal 0. And cos equals 0 at pi by 2, 3 pi by 2, by 5 pi by 2, and so on. Okay, so I want this to go there. So if I put n equal to 1 in, I get 3 pi by 4, which is 0. Put n equal to 2 in, then I get 3 pi by 2 and 0. Therefore, if n equals 2, then the cos of 6 pi over 4, which is the cos of 3 pi by 2, equals 0. Therefore, imaginary when n equals 2. These are the first values. Obviously, it happens. It's on a cycle, so it'll happen frequently. But I wanted the smallest integer n.